3.2 billion light-years from Earth, a group of astronomers have captured live with Hubble something they never thought they would get to see.
This is the Hubblecast. News and images from the NASA ESA Hubble Space Telescope. Travelling through time and space with our host, Dr. J.
There are many galaxies of different shapes and sizes in the universe around us today. Now, roughly half are gas-poor, elliptical-shaped galaxies with few new stars forming today, whereas the other half are gas-rich, spiral and irregular-shaped galaxies with lots of new star formation activity. Now, observations have shown that the gas-poor galaxies are most often found near the centers of rich galaxy clusters, whereas the spirals spend most of their life in solitude. However, observations of the deep and very far away universe have also shown that when the universe was roughly half of its present age, things were very different. Back then, only about 1 in 10 galaxies was a gas-poor one. So the question is, where did all of today's gas-poor galaxies come from? Apparently, there must have been some kind of transformation process. But because galaxy evolution takes place over billions of years, astronomers have so far not been able to see it live.
New observations with Hubble by an international team led by Luca Cortesi of Cardiff University, United Kingdom, provide one of the best examples to date of this metamorphosis.
Well, we were looking at the Abell cluster 2657 and we realized that this galaxy was falling into the cluster center at a velocity of approximately 3.5 million km per hour.
Abell 2667's enormous gravitational field is generated by the combined contribution of the cluster's dark matter, hot gas and hundreds of galaxies.
As the galaxy plows through the cluster, its gas and stars are being stripped away by the hot plasma in the cluster, which can reach temperatures as high as 10 to 100 million degrees. Also contributing to this destructive process are the tidal forces exerted by the cluster. These are just like the tidal forces of the Moon and Sun, which push and pull the Earth's oceans.
Both processes, the tidal forces and the aptly named ram pressure stripping, resulting from the action of the hot cluster gas, resemble those affecting comets in our solar system. For this reason, scientists have nicknamed this peculiar spiral with its tail the Comet Galaxy.
We see a unique galaxy that is being transformed by the fact that it's falling toward the cluster center. And what we see exactly, it's a kind of a spiral galaxy with lots of gas. And we see a trail of stars, of blue forming stars, and also around those stars some kind of wispy gas stripped away by the fall.
Furthermore, millions of now homeless stars have been snatched away from their mother galaxy, which will lead it to age prematurely. Even though its mass is slightly larger than that of the Milky Way, the spiral will inevitably lose all its gas and dust, and hence its chance of generating new stars later, so it will probably become a gas-poor galaxy left with an old population of red stars.
However, in the midst of all this destruction, the cluster's strong tidal forces have triggered a baby boom of star formation.
Hubble's sharp eyes have caught other spectacular effects of Abell 2667's immense mass. The giant bluish arc seen just off-center is the magnified and distorted image of a distant background galaxy seen through the gravitational lens formed by the tremendous mass concentration of the cluster. At the cluster's center, another rare feature can be seen. The vivid blue light from millions of stars created in a so-called cooling flow. Some of the hot cluster gas is cooling in a filamentary structure as it falls into the cluster's core, setting off the birth of lots of bright blue stars outshining their environment. This may be the clearest picture of this phenomenon yet.
By combining the visible, infrared and X-ray views from Hubble, Spitzer, Chandra, the VLT and Keck, we can see that this discovery adds a new brushstroke to a painting where galaxies are being slowly shaped by their violent interactions with the cluster environment. Although there are many discoveries still to come, the emerging elements shed new light on the painting's mysterious nature and are revealing some of its hidden wonders. This is Dr. J signing off for the Hubblecast. Once again, nature has surprised us beyond our wildest imagination.